Hello, ladies and gentlemen, and welcome to Unit 5, Day 6. We're going to be talking about recursive sequences. Okay, so we're going to be still looking at arithmetic and geometric sequences, but we're going to be rewriting the formulas for these guys in a different manner. Okay, so what we've been learning thus far is how to write it in the explicit form. Okay, so the explicit formula looks like this. A sub n is equal to a sub 1 plus d n minus 1, or a sub n is equal to your first term times the ratio raised to the n minus 1. This is your arithmetic, and that is your geometric. Okay? So those are the explicit formulas, and they call them explicit formula because it is a formula, all right, which can be directly evaluated without knowing the other terms. Okay? So what that means is, using those two formulas, all right, we can find any term in the sequence. Okay? Without knowing the previous term, the term after, okay? We just have those formulas, and we substitute in for n whatever particular term we're looking for, right? So the difference between explicit and recursive is recursive, okay, is a formula which uses the answer from the previous term to calculate current term. Okay? And so those are the difference between the two. All right? Now, guaranteed way of knowing if a formula is recursive or not is whether or not the function name is on both sides of the equal sign. Okay? And then finally, recursive formulas can be written in two formats, which we will see below, but they must include the first term. Okay? That's a big part here, right? Because in order to calculate the next term, well, we need the previous term, and the most previous term you can get would be your first term, right? So anyway, that's what we're going to be taking from this lesson. We're just going to be writing these arithmetic and geometric sequences in a different format, but still get us the same terms in the sequence, okay? So, important points for recursive formulas. The subscripts name terms. They are not values in the problem, okay? So again, you know, same things apply, right? This right here means your fifth term, right? And so, if a sub n is, or I'm sorry, if your a sub n is a sub 5, well then anywhere you see an n, you would put that 5, right? So looking down at the ones below, our examples here, our fifth term would be a sub 5 minus 1 plus 5, which says your fifth term is equal to 5 minus 1 is 4, so your fourth term plus 5, right? So in order to calculate our fifth term, right, we need our fourth term. Okay, same thing with down here. If you're looking for our, well, in this case, let's say, you know, we want to find our sixth term. Okay, well, 5 plus 1 is equal to 6. So in both cases, well, I'm sorry, let me rewrite that. Ayo. If we're looking for our fifth term, it's going to be 4, and this will be 4 plus 1, and 4 plus 1 is equal to 5. Okay, so again, in both cases, right, our fifth term is calculated by utilizing the term prior, right? So this is where this next part comes in. If the next term is a sub n, then the term before it would be a sub n minus 1, because n minus 1 is smaller than n, right? So in this case right here, right, when you're finding your fifth term, then a sub n minus 1 is your fourth term, right? The term that comes before. And then over here, right, if the next term is a sub n plus 1, then the term before it is a sub n because n is smaller than n plus 1. So same thing here, right? When you're finding your fifth term, right? So this is your a sub n plus 1 is equal to your fourth term, right? Because a sub n is 1 less than n plus 1. And so anyway, basically in both cases, right, these terms, right, your fifth term is equal to your fourth term plus 5, right? And so moving down here, oh, and always build off the last term. Okay, that's important. Okay, so if we wanted to calculate our sixth term, right, well, we need our fifth term plus 5, and so on and so forth. Okay, so we always build off the last term. All right, so without further ado, let's get into some actual mathematics. You can see what's going on with these guys. Okay, now, these are both the same equation, okay, same recursive formula, except just written differently. Okay, so when you go to rewrite these formulas, right, these are just a couple ways you could represent the same sequence. Okay, so it says write out the first 4 terms. Okay, so I want to find the second term, right, because we already have our first term. And so our second term is equal to our 2 minus 1 plus 5. And what's 2 minus 1? Well, that's 1. And so our second term is equal to that. So a sub 2 is equal to 3 plus 5, which is 8. Okay, there's our first term in the sequence, or our second term, sorry. Our third term would look something like this. A sub 3 is equal to our second term plus 5. And so this would be 8 plus 5, which is 13. And then our fourth term is going to be a sub 3 plus 5, which is equal to 13 plus 5, which is 18. So our first 4 terms are 3, 8, 13, and 18. Okay? And so when they say write it out, this is what they want to see. Okay? And again, these sequences are built off by using the term prior, right? So as you can see, that term prior is always the first number in these formulas here. All right? So if we go over to the other side, okay? So let's say we want to find the second term, right? So we have our first term plus 5, and so 1 plus 1 will give me my second term. So a sub 2 is equal to a sub 1 plus 5. And again, we have our first term, which is just 3 plus 5, which is equal to 8. And then a3 is equal to a2 plus 5, which is 8 plus 5, which is 13. And then finally, fourth term is equal to the third term plus 5. 13 plus 5 is equal to 18. Okay, so again, 3, 8, 13, 18. First 4 terms. Okay, so let's check out the one down below here. All right, so same sort of process. It's asking us to write it out. Okay, that's fine. So b sub I is equal to b sub I minus 1 plus 4. So in this case, I want to find the second term. So it's going to be our first term plus 4, which is our first term is 7. So 7 plus 4 will give me 11. And then our third term is going to be our second term plus 4, which is equal to 11 plus 4, equal to 15. And then b sub 4 is equal to b sub 3 plus 4, 15 plus 4, 19. So 7, 11, 15, 19. Okay, and again, this is our first term, and this is what we were adding each time. Now, key thing to point out here, okay, these first couple are arithmetic. Okay? Arithmetic, sorry. Okay? And how you can tell is by this guy right here. Okay, what operation are we performing at the end of these guys? All right, this lets us know, all right, what we're doing from term to term. So when you're adding a number, right, we're not multiplying, we're adding some number each time, that lets us know they're arithmetic. You look down below, right? The reason why I bring this up, because if you look down below, if you look right here, what operation are we performing? Multiplication, right? So when you go to write these, multiplication, when you go to write these, or when you're trying to, decipher what kind of sequence we're talking about here, that's where you want to look, right? So if you see multiplication back here, geo, addition, or subtraction, right? Because you can add negative numbers, it's going to be arithmetic, okay? So, that being said, all right, let's find our second term. Our second term is going to be our first term times 3. Okay, and so our first term is 2. 2 times 3 is 6. So there's our first term. All right, our second term is going to be c sub 3. It's equal to our second term times 3. Our second term is 6 times 3, 18. And then finally, c sub 4 is equal to c sub 3 times 3. And so 18 times 3 is equal to 54. Okay? So those are our 4 terms, right? They gave us our first one, though. And that's another thing you're going to see in all of these, no matter if it's arithmetic or geometric, okay? They have to give you your first term. Otherwise, there would be no way of computing this, right? Because we would have no idea what to multiply 3 by. And so in this case, it's always you're always going to get the first term. Okay? So we're going to go 2, 6, 18, 54. Okay. So that being said, all right, hopefully that makes a little more sense. Let's go down to actually writing these guys. Now, writing them is really kind of a snap, guys. Okay, so when you're writing recursive formulas, okay, we cannot use our calculator. All right, so we cannot use regression, which is okay because we don't even need it anyway. It's really not that bad, I promise you. Okay, now all of them either start out like this or like this. Okay, and so if you look up in the top, right, those are the only, well, I mean, they have C and B there, right, because, they always like to mix things up, those Regents problems. But as you can see, right, they have pretty much the same format, except they, don't have A sub n in there, all right? So in this one they have B sub n's, number 3 they have C sub n's, but number A, letter A, or number 1, they have A sub 1's in there, okay? So just sometimes you got to be careful with your, your Regents problems. They like to use different letters to just sort of throw you off. But when we go to write these, okay, we're always going to stick with the A sub n, right? So don't worry about any other letters but those, just that letter right there, A, and then n plus 1 or n minus 1 on either side, okay? Now, again, for all of these, right, these recursive formulas, okay, one way you could tell, remember right from the notes, I said that the function name is on both sides of the equation, right? So b sub I there, c sub I there, okay? So that lets you know that they're recursive, right? And so when you go to write these, they're all going to kind of look the same except for whether or not we're adding or multiplying depending on the type of sequence, okay? So you're going to start with either one of these. Now, I tend to gravitate towards this one. This one computes better in my mind, but either one is fine, okay? It's whatever your preference is, all right? So it's giving us a recursive, or it's asking for a recursive formula down here, okay? So let's take a look. It looks like we're adding 10 each time, okay? So it's definitely arithmetic, okay? If we wanted to write the explicit formula for this, it would be a sub n is equal to, our first term plus d n minus 1. So in this case, a sub n is equal to 2 plus 10 n minus 1. Okay, that's the explicit version. They want the recursive version. Okay, so I'm going to pick this guy here. A sub n is equal to a sub n minus 1. We're adding 10 each time, and then we also need to include our first term. And so that is the recursive formula for that sequence. Okay, and that's it. And then that, based off what we see here, we could find any term we wanted in the sequence, right? Our second term is equal to our first term plus 10. Our first term is 2 plus 10, 12, right? Third term is equal to our second term plus 10. 12 plus 10, 22. All right, so yeah, these can be utilized. Either one, they're both arithmetic. They both refer to the same sequence, just a different representation. Okay, number 5. All right, again, they throw this p of n in there. Okay, write the recursive formula. Now, it looks like we're multiplying by 4 here. Okay, so we're multiplying by 4. All right, so this is going to be some sort of geometric. Okay, also, if we wanted to write the explicit formula for this, we would go negative 2.5 times 4 raised to the n minus 1. All right, so if we want to write the recursive version, times 4, and then a sub 1, our first term is negative 2.5. Okay. All right, a couple more word problems, everybody's favorite, and we'll call it a day. So this kind of ties back in with our exponential growth and decay problems. Okay, so let's read the problem and you'll sort of see what I mean here. All right, so write a recursive formula to represent starting with a pile of 120 and using 20% of them each day. Okay, so let's just write out some of our first terms. Right, so here's our first day. Right, we've got 120 boards. Okay, and we use 20% of them. All right, and so our second day, we have 96 left. Okay, so our third day, well, we're going to use 20% of that again. And so now we're down to 76.8 logs, right? Probably wouldn't have a 0.8 there, but that's about where we're at. And then, again, that day, we used 20% of that. Okay, so 76.8 times 0.2. Now we're down to 61.4. Okay, so the question is, right, because our sequence is referring to how much of the boards we have left, right? We're not talking about how much we're using each day. We're talking about how much we're starting with a pile, using 20%. How much of that pile do we have left? Okay, so in retrospect, we're not multiplying by 0.2 to get from term to term. Okay, we're actually multiplying by 0.8. 120 times 0.8 is equal to 96. What we're multiplying by is essentially how much we have left. Remember our rates when we're doing decay, right? It was 1 minus r. And so in this case, right, 1 minus 0.2 gives me 0.8. Okay, so that's what we're multiplying by each day here. All right, and then I'm going to write the recursive formula. So a sub n is equal to a sub n minus 1 times 0.8. And we need our first term, which is 120. Okay. Down below, this one is a, let me rewrite that up here so it looks a little neater. Decay. This is a growth problem. Okay. what's happening here is we're starting with 50 boards and we're stacking 40% each day. So what we're multiplying by is essentially, 1 plus 0.4, which is equal to 1.4, right? So I could have gone, what I did in the last one, but I just took into account, okay, we're multiplying by 40% of what we had the day before, right? So an extra, 1, right? 1 plus 40% of that each day. So anyway, hopefully you guys probably saw that. Penny, you're on the video. All right, so we're starting with 50, right? And then after the second day, right, we use 40, or we're adding 40%. So whoops, did the math wrong there. All right, so the next day we're up to, whoops, not 20%. We're going to add 20, so 70. The next day, going to be 90, whoops, 84, sorry. 84. Next day, whoa, hold on a second, I messed up there. Skirt. 50, day 1. Day 2, right, 20% of 50, holy moly. Or 40%, come on. 20, right, so that's 70. Third day, so 40% of 70. 28, so that's going to be 98, there we go. Okay. Fourth day, 40%, 98. 98, what's that? Looking at about 137.2. Okay, so in retrospect, what are we multiplying by here to get from term to term? Okay, we're adding 40%, right? But what we're actually multiplying by is 1.4. Okay, so a sub n is equal to a sub n minus 1 times 1.4, first term, 50. Okay, I'm trying to rush through this last part here. So write a recursive formula for the following sequence. Always starts out the same. So I can just start with both of those right there. And then in each case, looks like we're multiplying by a -2 here. Need our first term. It looks like we're adding 5 here. And again, need your first term. Okay? So anyway, that is the lesson on recursive sequences. Okay, lot to go through there. All right, so I apologize for the length of the video, but again, I'm only asking you guys to do the odd problems. Okay, so hopefully if you're watching this, you're either trying to get caught back up or maybe you needed to go back for a reference. But anyway, hopefully this helps, and have a good day.